on to look at the rest of the female reproductive function in kind of the long-term regulation. So let's talk about the phases here again. So we had puberty, and puberty was that phase, that initial phase of the development of the secondary sex characteristics in females. It was also the beginning of ovulation in females. And then the hormone estrogen is what's responsible for the production of the secondary sex characteristics. So the initiation of ovulation and the beginning of the production of estrogen is what is also triggering the development of the female phenotype. We have the widening of the hips, we have the deposition of fat in the breast area, in the hips and buttocks, which are kind of synonymous with the female physiology. We have oilier skin, other body hair changes, and then specific growth of certain bones that are going to differ significantly to the way that testosterone triggers growth development, muscle development, and bone development. Then we get to the reproductive years, which are typically beyond puberty all the way up until menopause, and estrogen levels remain high and are what help to maintain the secondary sex characteristics throughout the rest of the reproductive years up until menopause. So at menopause, estrogen levels decrease. This is where we have reversal of some of the secondary sex characteristics. We see atrophy of the breast, usually atrophy of the uterus. We see atrophy of the vagina. The vagina becomes dry. We see hot flashes. We see increased risk of heart disease and osteoporosis. So we pretty much lose the characteristics that are associated with fertility, and we no longer have ovulation. Now, estrogen is typically a protective hormone in terms of preventing heart disease, in terms of preventing bone fractures, and so on. And so when we drop this estrogen level, we start to see these adverse effects such as heart disease and osteoporosis because we no longer have the protective effect of estrogen. This is why we typically say that men are more likely to get heart attacks. So men don't have estrogen in the same quantities and proportions as women do, and so they don't have that added protective measure of estrogen. But after menopause, the risk, the likelihood of a heart attack is kind of equal between men and women, whereas before menopause, women are less likely, men don't have that added benefit. And there's some kind of correlation there with evolution, the fact that the female is more closely required for the offspring, for the production of offspring, because they are actually carrying the offspring. So during their fertile years, they need a little bit of added protection in order to help with reproduction and the production of new offspring. Okay, we're going to skip over these checkpoint questions and we are going to move on to our next objective. I did want to mention here in terms of estrogen, this is why we give hormone replacement therapy. So hormone replacement therapy is essentially exogenous estrogen that's given that helps to alleviate some of the adverse effects that are seen with menopause. Now, the flip side of this is that excess estrogen that could be stimulated if you replace estrogen with hormone replacement therapy do have other adverse effects as well. And this is the kind of nuance, the trick with reproductive endocrinology and endocrinology in general, is that hormones need to be in a very delicate balance. They're creating certain effects in the body at very specific levels and proportions. And if you have excess, you end up with some type of pathology, dysfunction. But if you have too little, you end up with dysfunction and pathology as well. And so we see that with thyroid hormone, we have hypo, hyper, with cortisol, we have hypo, hyper. We see that with even the pituitary hormones, LSH, FSH. They're needed in very regulated, very strict proportions. Otherwise, we can see pathology on either side. Okay. So our second objective here is to describe the events that occur during fertilization, implantation, and then in early embryonic development or early gestation. So fertilization usually takes place in the uterine tube. That's where it's supposed to take place. And this is along the journey as the ovum makes its way out the fallopian tube. So in strict terms, it should actually take place 2/3 the way along that tube, meaning that the sperm should be introduced into the female reproductive tract within 5 days or so of ovulation, either before or after, because they can kind of survive for quite a few days in the uterine cavity in the reproductive tract. And they should make their way up into the uterine tube, whereas the ovum is making its way coming in from the fimbriae, also traveling in the uterine tube, and they should meet somewhere along 2/3 the length of that tube. So this is a very small window for ovulation because sperm are viable for about 5 days, whereas an oocyte is only viable for about 12 to 24 hours. So there has to be kind of a very specific timed component in order for fertilization to take place. Also, you do have what we call ectopic pregnancies, which is where fertilization takes place somewhere inappropriately along that tube, and we end up having implantation happening in the tube itself, and that will obviously be detrimental as that fetus, that embryo begins to grow in the tube and will eventually cause rupture of the uterine tube. Now, in order for fertilization to take place, there's a process called capacitation that needs to happen. This is where the sperm has to change itself. It undergoes biochemical changes to the plasma membrane that are required in order for it to burrow itself into the ovum and to complete fertilization. So one of the sperm has to undergo capacitation, which kind of gets it ready for the reaction that's required for it to enter the ovum and fertilize that ovum. Now there's a certain amount of fluid that's moving into the uterine tube. And if you remember the parts of the uterine tube, we kind of talked about them in lab this week. So we have the fimbriae, and the fimbriae are like the finger-like projections that are sticking out and coming in contact with the egg. And so there's this peristalsis of the fimbriae and of the tube to kind of suck up the ovum once it is ruptured off of the ovary, out of that follicle, and to grab it up into the uterine tube and begin moving it. It's going to also grab some fluid with it, and that fluid is what's kind of going to gush it along the length of the uterine tube and bring it towards the fundus of the uterus and eventually into the uterine cavity. So we have a few features here that are helping with this movement. We have the peristaltic contractions of the uterine cavity. Remember, the uterine tube and the uterine cavity is nothing but smooth muscle. It's going to be rhythmically contracting. We also have cilia. So cilia are aligning the cells of the endometrium of the uterine tube that are helping to sweep this egg along with the beating motion of those hair-like projections, okay? Now this entire trip takes about 4 days or so from where fertilization happens in the uterine tube all the way to where it gets into the uterine cavity, and then it can be implanted into the endometrium there. So the sperm must meet the ovum anywhere within these 4 days. Otherwise, we will not have fertilization taking place. The oocyte will no longer be viable. Okay. If fertilization does take place, so we have lots of sperm being deposited, millions of sperm being deposited into the vagina, sperm are going to make their way up the uterus. So remember, they have that motility that's caused by the tail. They got lots of mitochondria for the journey. They're going up the uterine cavity, into the cervix, into the os, into the uterine tubes. And again, they're going to be viable for about 5 days. So they got to make their way to the ovum before that 5 days is up. And they're going to undergo capacitation, which is required before they can actually burrow and fertilize the oocyte. They're going to have to remove their tail. They're going to have to alter certain aspects of the plasma membrane. Remember, we have the acrosome, which is in the head of the sperm that has all of the enzymes and the fructose that's providing the energy. All of those components are going to be required for capacitation, and then capacitation is going to lead to the acrosomal reaction, and that is what creates the burrowing of only one sperm. Now, typically only one sperm can burrow into the ovum, into the corona radiata, which is that ring-like layer around the ovum, and bring about fertilization. Now, typically, again, only one sperm can do this, but we do have anomalies with human physiology, with humans in general, right? So we do have instances where two sperm can burrow in, and that is obviously going to give us a split in the embryo, which could be a route to leading to twins as well. Okay, let me pause here and see if there are any questions. So our third and final objective is to describe the regulation of estrogen and progesterone secretion during pregnancy and explain how these hormones help to maintain pregnancy and prepare the body for parturition, and parturition is birth, okay? So this is really just an overview of the hormones that we talked about before. So this is what's happening specifically if fertilization does in fact take place. So estrogen is going to spike in its secretion. We have estrogen now coming from the corpus luteum that's helping to sustain the first part of this pregnancy. And then eventually it's going to be taken over by the placenta. It's going to help with the growth of the breast, prolactin secretion. It's also going to help with the contractile responsiveness of the uterus, as well as the production of oxytocin. All of these are hormones that are preparing the body for gestation, or maintaining gestation, I should say. And then progesterone is going to be even more important here. It's going to help with the glandular tissue of the breast. It's going to help to maintain the uterine lining, which is ripe for that pregnancy. But it's going to be suppressing contractile activity of the smooth muscle of the uterus. And that contractile activity would otherwise promote the sloughing off or the menstrual flow. And because we don't want that, that is going to be suppressed by progesterone. So we can see here that the increase in estrogen and the increase in progesterone really are sustained throughout the pregnancy. So on the x-axis here, we're seeing the months from the last menstrual period all the way to parturition. And we can see that estrogen and progesterone are sustained throughout the entire pregnancy, starting off with their production from the corpus luteum, and then eventually being sustained from the placenta all the way through to birth. We also see another important hormone called HCG. HCG called human chorionic gonadotropin hormone. This is secreted from the placenta. It's what sustains the corpus luteum. So let's kind of back up here. If you remember, I told you that the corpus luteum needed to secrete estrogen and progesterone to maintain the first part of the pregnancy. Now, the signal for the corpus luteum to do so is actually coming by way of this HCG hormone from the placenta. So when that embryo is first implanted, it's going to start secreting HCG, right? It's going to develop one part that's going to actually begin to secrete the HCG, and that HCG is actually a communicating signal to tell the corpus luteum to continue secreting estrogen and progesterone. Otherwise, the corpus luteum would degenerate. So it's really a signal from the embryo to the corpus luteum to say, hey, we've got fertilization on this side. Please keep the estrogen and progesterone coming and do not degenerate, okay? And then eventually, when the placenta grows enough, it's going to take over the role of secreting these hormones, estrogen and progesterone, that are going to be sustained throughout the rest of the pregnancy. And that corpus luteum, again, will eventually degenerate when the placenta takes over. Now, progesterone, as it rises, is going to have an inhibitory effect on the hypothalamus for GnRH secretion and on the anterior pituitary for FSH and LH secretion. And this is what's going to prevent a new LH surge. This is what's going to prevent you from ovulating if you are already pregnant, right? This is what prevents pregnant women from continuing to get pregnant. So it's going to have what's the word I'm looking for? It's going to have a kind of a birth control effect on the human physiology in preventing new pregnancy. And this is what birth control actually sometimes mimics. It mimics the hormone levels that would be seen in pregnancy, and it tricks the body into thinking that it's already pregnant, therefore preventing a new pregnancy. So it's kind of unique trickery in making the hypothalamus and the pituitary specifically think that pregnancy is already happening because of these sustained levels of estrogen and progesterone, and so it prevents a new LH surge or a new ovulation from taking place. Okay. All right, so here is, again, an overview of this flow of events here. We have HCG spiking. Now, HCG is actually the pregnancy detector. This is the hormone that is measured in home pregnancy tests and the P-stick pregnancy test. This is what's detected in your blood, in your plasma level, but also in your urine. And so physicians, as well as women at home, can look for this hormone in their urine or in their blood to determine if the fertilization has taken place, implantation has taken place, and we now have the exponential growth of this HCG hormone. So as we see, it's rapidly rising within the first trimester. So month 1, 2, and 3, we see the rapid spike. So this should be growing, doubling every day throughout this first part of the pregnancy. And then it should eventually taper off by the second trimester and kind of tamper down until parturition. So it's really only required to kind of jumpstart the pregnancy. It's the communicator to tell the corpus luteum to continue secreting those hormones. And so beyond that first kind of jumpstarting of the pregnancy, it's no longer needed for the rest of the pregnancy. Estrogen and progesterone are now being produced by the placenta itself. And so we no longer need to tell the corpus luteum to secrete these hormones, okay? I hope that kind of makes sense there.